Hi everyone. So first of all, these are the six questions I shared today for you all to solve. Let's discuss one question at a time. So this is the first question based on polygons. So here they've asked you ABCDEF is a regular hexagon which we already have over here with each side of length 1 centimeter. The area in square centimeter of a square with AC as one of its side. So if I know the length of AC, if AC is x, then the area of square is equal to x square. So we just have to find the length of AC. In a hexagon, we remember that each angle is equal to 120 degree. To get the length of AC, what we'll do is we'll draw a perpendicular on it from here. So if I draw a perpendicular, this 120 degree of here is divided equally as 60 degrees and 60 degrees. So this becomes a 60 degree, 90 degree. So this angle will be a 30 degree. If you remember, the side opposite 60 degrees is, so let us say this point is some x. So ax would be equal to, side opposite 60 degrees is root 3 by 2 times the hypotenuse. Or you can remember this as the height of an equilateral triangle. Remember? So this will be root 3 by 2 into 1, which is nothing but root 3 by 2 ax. Now this, when I draw this perpendicular, this was also equally divided. So AC is equal to twice of ax, which will be equal to root 3 by 2 into 2. So that will be nothing but root 3. So if AC is root 3, area of the square will be equal to root 3 square, which will be equal to 3. And hence our answer would become option 2. Okay. Now moving to the second question. Base of a vertical pillar with uniform cross section is a trapezium whose parallel sides are of the lengths 10 centimeters and 20 centimeters. So I've already taken a trapezium. This side is 10 and this side is 20, while the other two sides are of equal length. The perpendicular distance between the parallel sides of the trapezium is 12 centimeter. So these two are divided by a height, or the trapezium has a height of 12. So I'll just draw it here as well. 12. Alright. And the other two, the non-parallel sides are equal. So this is equal to this. The perpendicular side is, if the height of the pillar is 20. Now, the important thing is pillar of uniform cross section of trapezium. So remember when we were doing cylinders, we had discussed a concept called prism. Prism is a concept where the area of the cross sectional area remains the same. So while doing this, we had discussed a couple of things. One thing was the the lateral surface area, that is the vertical area of the vertical walls. Lateral surface area of a prism is, lateral surface area of a prism is equal to the base perimeter into height. So here, instead of the base being a circle, the base is a trapezium. So it's a trapezoidal prism, something of this sort. Okay, you get my point. The shorter side is hidden behind, so maybe something like this. So this is the kind of cylinder that we have here, the prism that we have here. All right. So the lateral surface area is this, but we wanted the total surface area. So total surface area is always, total surface area will be equal to the area of the top, the area of the base plus this. So 2 into base area plus base perimeter into height. All right. So it's actually more based on the base. So let's come to the base. So this was our base, the trapezoid. All right. The base was this. First of all, can we find the perimeter? For the perimeter, we need both the all the four sides. We know the two parallel sides. So can you find the two non-parallel sides? I believe yes. If this is 10, we've drawn the two heights. The distance between those two heights will also be 10. The remaining 10 out of this 20 will be divided equally year and year. So 10 divided by 2, this will be 5 and this will also be 5. And 12, 5, we remember triplet 5, 12. We remember triplet 5, 12 and 13. So this hypotenuse would become 13 and this will also become 13. So now we know the perimeter of the base. We also know the formula for area of the base. So base perimeter is how much? 20 plus 10, 30 plus 13 and 13, 26. So base perimeter is, this thing is 56. Height of the trapezoid, height of the prism that we have is 20. So this height is 20. This is for one part and 2 into base area. So area of the trapezoid, area of the trapezium is how much? It was half into sum of the parallel sides, that is half into 10 plus 20 into the distance between the two parallel lines, which we call the height of the trapezium. So here this will be 12, 2 goes once, 2 goes 6 times, 10 plus 20, 30 into 6, the base area would become 180. Okay, so if you come to this becomes 2 into 180 plus 56 into 20 is 1120. 1120 plus 360, this will become 1480. So the answer would be option 3. Okay. So now coming to the next question. ABCD is a quadrilateral inscribed in a circle with center O. COD is 120 degrees and angle BAC is 30 degrees. So let's just draw the line BAC. Let's use a different color to avoid some confusion. So use a black pen. And I first draw this line. This goes till C. So BAC, they've given you that this angle is 30 degrees. I hope you're comfortable. We had a quadrilateral in a circle. Center of the circle is O. One of the sides CD makes an angle of 120 degrees. BAC makes 30 degrees. Alright. So now what we had to find? We had to find the value of angle BCD. BCD. Remember, this is a cyclic quadrilateral. In a cyclic quadrilateral, opposite angles are supplementary. So basically, angle BCD plus angle BAD, opposite angles are supplementary. So these two angles are supplementary. So I don't know BCD, but I have been given some information for angle BAD, out of which BAC is 30 degrees. So if I'm able to find this angle, I think my question would be solved. So what can you comment about angle DAC? Angle DAC. Angle DAC. So if I look at angle DAC is the angle made by the chord CD on the circumference. Angle on the circumference we had discussed is half of the angle made at the center. So that is why angle at the circumference DAC will be half of 120, which will be equal to 60 degrees. So here we get this angle is equal to 60 degrees. So If this is 30, this is 60, angle BAD becomes 90 degrees. But angle BAD is supplementary to angle BCD. So therefore angle BCD also becomes 90 degree because we had this relation. Right? So 90 degrees is the answer. So answer to this is 90 degrees. Fine. So that was not very difficult. Okay. Then coming to the next question. If three sides of a rectangular park have a total length of 400 feet, then the area of the park is maximum when the length of its longer side is. Right? Now, first of all, you've been given, say, sum of three sides. So let us say this side is like two sides are x, basically two sides are equal, so two sides would be x and two sides would be y and y. I don't know which is longer, which is shorter, but you'll come to know when we start solving the question. So we know sum of three of the sides is equal to 400. So let us say, okay, one x, one y, and one of them will have to be the same as the other. So let us say these two. So can I say 2x plus y will be equal to 400? Okay, 2x plus y will be equal to 400. And they've asked you when the area would be maximum. So we have to maximize the area. We have to maximize the area of the rectangle will be maximum at some value of x. The area will be maximum at some value of x. We have to find that value of x. Now, while we go into the algebra module, we'll get into the maxima minima concept. And there you'll realize that if a plus b is equal to some constant, say 10, then a into b will be maximum when a is equal to b. The point being, suppose a plus b is 10, they could be 5 and 5. 5 into 5 is 25. They could have been 4 and 6, but if you will see, if you don't keep them equal, the multiplication will keep on reducing. 4 plus 6 is 10, but 4 into 6 is 24. 3 and 7, had you taken them as 3 and 7, 3 into 7 would have been 21. So the product would have been maximum only when you take them equal. Using the same concept here, the variables here are not 2x, basically x and y, but we have the addition of 2x plus y as 400. Nothing to worry. If 2x plus y is 400, we can say 2x into y will be maximum when 2x is equal to y, isn't it? When 2x is equal to y, the product would be maximum. Can I say that? Obviously, yes, because 2x plus y is a constant and the multiplication would be maximum when both the variables are equal. What's the relation of 2x into y with x into y? So if 2x into y is maximum, if I just remove the 2 out of it, if I just ignore the 2 out of it, x into y will also be maximum. So therefore, x into y, or the area, will be maximum when 2x is equal to y. So I wanted the longer of the two sides. You'll realize if 2x is equal to y, if 2x is equal to y, you can put 2a instead of 2x, you can put a y. Y plus y, 2y will be equal to, from here you'll get 2y will be equal to 400, and you'll say y is equal to 200. If y is 200, 2x is also equal to 200. x would be equal to 100. X becomes 100. So for the rectangle, the shorter sides are 100 and 100. The longer sides are 200 and 200. And we've solved this keeping in mind the condition that area should be maximum. So that's why the longer side, when I want the maximum area, would be 200. So the answer to this question would be 200. The longer side has to be 200. The shorter side has to be 100. In that case, your area would be maximized with the given condition. Coming to the last question. Let P be the interior point of a right angled isosceles triangle ABC. First of all, when you read this right angled isosceles triangle, the first thing that should click you is it's a 45 45 90 triangle. So I've drawn a 45 45 90 triangle, and in a 45 45 90 triangle, we know if the two perpendicular sides are x and x, because it's an isosceles triangle, the hypotenuse is root 2 times the x. So I've drawn all those things. Further, you've been given, if okay, there's a point P inside. There's a point P inside whose perpendicular distance from all the three sides is the same. So perpendicular distance from here, perpendicular distance from here, and perpendicular distance from here is the same. So they've used an indirect way of trying to say something. This is the point P. This point P actually is the in center. In any triangle, whenever you draw an in circle, the in radius is the perpendicular distance of that point of the center from all the three sides, and it is equal. So this point P is the in center, and these distances are nothing but the in radii that we generally represent by small r. And we have a formula for in radius of a right angle triangle. Remember, in radius of a right angle triangle has a formula a plus b minus c by 2, where a and b are the perpendicular sides, c is the hypotenuse, the whole divided by 2. So this we know is 4 root 2 minus 1 is equal to, all three sides are in terms of x, so we'll get the value of x. So that will be x plus x minus x root 2 the whole by 2. So this will become 2x by 2. So can I say that will become x minus x root 2 upon 2. So that will be x upon root 2. If I multiply root 2 over here, all right, if I multiply the root 2 over here, I'll get x by root 2 into root 2 minus 1 is equal to 4 into root 2 minus 1. The root 2 minus 1 from both the sides gets cancelled, and we get x is equal to 4 into root 2, taking this on this side. So if x is 4 root 2, this x is also 4 root 2. Area is half into base into height, half into 4 root 2 into 4 root 2. Root 2 into root 2 is 2. So this root 2 gets cancelled. 4 into 4, the area will become 16. So what is the area of the triangle? Area of the triangle is 16. So this way, all the 5 questions were easily solvable, not too difficult. You could have done it. I hope the solution helps. Thank you.